So I've been thinking about this quote a lot over the last 18 months. Any of you who have worked in data pipelines or worked with data where you're using kind of interpreting human created data elements is familiar with this quote, which is some people when confronted with a problem think, I know, I'll use a regular expression. And now they have two problems. They're brittle, they're fragile, you have to test them against it. It's a big pain in the butt. And I've been thinking about this a lot because I think you could reapply this incredibly easily and say, I know I'll use prompting. And now you have two problems. Prompting has been a game-changing element, probably one of the things that are responsible for the large success and embrace of LLMs over the last 3 years. They are amazing, but they are a gift and a curse. They are a gift because anyone can describe programs, functions, and tasks, especially the domain experts that you need to kind of start to code your eval data and make sure your pipelines are doing the things you want them to do. They can be written quickly and easily. I was advising a group of students who are building applications on top of Overture Maps data. And what's great about that is everything goes into the LLM first, then you optimize it out into more repeatable and scalable functions as you start to develop that pipeline. It lets you get started so quickly. The other nice thing about prompts is that they're self-documenting. You can kind of read the prompt and have an idea of what the program is supposed to do. But prompts are also terrible, and they're especially terrible when they're buried within applications and pipelines. They perform differently for different models. This is an incredibly under-discussed facet of prompting, is that we can take a benchmark model performance, which they've been trained against with reinforcement learning, and then we change the wording just slightly, and the score falls through the floor. It is not a discrete one-to-one interaction, and you can have varying results with just slight changes if you change up your model. The second issue is that prompts become a catch-all. I recently was analyzing the system prompt that was extracted from Claude, both 3.7 and 4. And one of the things I found is that kind of the development cycle within Anthropic is they just start putting in these hot fixes to solve it. It's just little one-liners that take care of a buggy problem. And then when they get to retrain the model into 4.0, those hot fixes are gone. It becomes this catch-all. And as your application or pipeline develops, your prompts will become a catch-all. They'll have all these weird statements that you don't really understand why they're there. How many of you have seen a comment in a code base that says, don't delete? That's the prompting equivalent of this. The other thing that really bothers me about prompts, especially when they're just stuck in line with code as just a formatted string, is that they contain multiple components, but you can't see those components. They're completely opaque. We do the same tasks all the time in prompts, but it still just appears like a block of text going on, in some cases, for pages. And let me show you what I mean by these multiple components. So I'm going to use an example prompt to kind of be our table of contents. This is from OpenAI's prompting guide. They give an example prompt for the prompt that performed best against SWE Bench. And I created a visualization, which is I read the prompt and went through it and I marked it up. And I organized it into these 6 components. You've got the task, which is only 1% of the whole prompt. You've got the chain of thought instructions, which ends up taking about 20% of the prompt. You've got detailed context and instructions about how you should be answering these questions and what you can do to answer these questions, the examples, some few shots in there. You've got tool definitions. In Claude's system prompt, it's like 70% tool definitions, just fills it out. And then you've got a ton of instructions on formatting instructions, because again, this is Git commits, so you got to be very, very explicit and repetitive about how to properly format Git commit. Something I've been tracking is how I have a theory that a lot of benchmark scores going up is just better formatting due to reinforcement learning, but we can talk about that later. And then you got this other at the end. But here's the problem. This is not what the prompt looks like when it's in your code. Looks like that. And that goes on for pages. It is opaque. So we think of prompts as this thing that anyone can understand, but when you're scanning it in a code base, it's terrible. And actually, this is a little unfair. I didn't turn on syntax highlighting. There's syntax highlighting turned on. There it is. Clears it right up. So this is the problem we're going to address today. So my name is Drew Breunig. I have a background in cultural anthropology and computer science. I help humans understand data and data understand humans. I've built award-winning quantified self apps. I ran data science and product at a startup called PlaceIQ for about a decade, using petabytes of movement data to understand human behaviors in the real world, which was bought by Precisely. And today, I consult with teams to help them explain their technology, and I work a good chunk of my time with the Overture Maps Foundation. Now, I'm going to talk about the Overture Maps Foundation because it's going to be our example project for today. We're going to make a real pipeline for Overture Maps. So how many of you here have heard of the Overture Maps Foundation? 2, 3. OK, that's great. I expected 0. Now, I love the Overture Maps Foundation because when I tell people what it is, they're like, well, why don't I know about that? And why am I not using it? Because it's kind of this incredible thing. So the Overture Maps Foundation produces a free open geospatial base and reference layer. So it tells you about streets, tells you about buildings, tells you about places, tells you about addresses, tells you about everything. And this is not just some podunk open project that is just something I've been working on. We've got almost 40 companies building this. It was founded by AWS, Meta, Microsoft, TomTom, and Esri has joined. We've got incredible companies in here, from Uber to Niantic to TripAdvisor to, and one of the things that's amazing about this is that this data is now being deployed in a lot of these people's maps. So billions of people are using this map information, and you could go use it today. It's free. It's unbelievable, and great licenses. Today, we're going to be talking about points of interest, or places. So these are things, businesses, schools, hospitals, parks. This is a data layer that has incredible, a really great license, doesn't need share alike or anything like that. It's primarily sourced from Meta and Microsoft's data. So this is like Facebook and Microsoft POI data that you can use. But we take multiple data sets. I think we have 4 or 5 places data sets now coming together, and we have to do what's called a conflation. If you've worked in geospatial, you know what a conflation is. It's a giant pain in the ass. It's the act of merging many geospatial data sets together so that I join the things that point to the same business in real world. Now, this is hard. It's a big pain. And the reason it's a pain is because place data is created by humans. There's bad data entry. You would never believe how many different ways there are to spell Walmart. It is unbelievable. I've seen them all. The other thing is you end up with similar regional names. How many of you are from or have been to Atlanta? Okay. Do you notice how everything is called Peachtree there? It's unbelievable. And so now you're trying to join Peachtree gas station with another Peachtree gas station down the block, and you're supposed to know those are 2 different things. At PlaceIQ, we had, my favorite example was 2 BP gas stations that were kitty corner, right next to each other. They had the exact same listing, just a slightly different address, off by a few latitude, longitude points. Also, the owners hated each other. It was near our office, so we couldn't do it. So, and then the bad addresses and geocoding. Address formatting is incredibly hard problem to solve, and you don't want to be doing it. So these are all the problems. So this sounds perfect for LLMs. It's human-created, messy data. Now, the problem with this is that we have 70 million places at last count in our pipeline, and we have to compare them against each other. So now you're looking at a monthly pipeline, and we're going to be deploying bi-weekly soon enough, and we can't put everything through an LLM. It just cost, speed, reliability, it does not make sense. So I'm sure because this is a Databricks conference, I can say things like compound AI, and you know what I'm talking about. So we use compound AI pipelines, doing spatial clustering, string similarities, embedding distances. There's lots of reasons. Most matches don't need an LLM. Most matches we can figure out ourselves. But then we bring the LLM in. Now, one of the problems with this is, you saw how many companies are part of Overture, right? Overture's matcher is maintained and edited by multiple people from multiple different companies, and they drop in sometimes, and then they might get transferred off to a different project. So having that big opaque prompt is actually a terrible idea for us. We strive to be cloud agnostic, we strive to be platform agnostic, and we strive to boot up everything really easily. We also may want to run it on different models over time. There's lots of things that we care about. So how do we solve this problem? And this is why I have become such a fanboy for DSPy. I have no idea if I'm pronouncing that correctly. But anyway, this is a framework that makes everything easier for us, and I'm going to show you why. But I think this is the crux. This is how I describe it to someone of why you should use this framework. Tomorrow, there are going to be better prompting strategies. There's going to be a new paper released on a new optimization methodology. And in 2 weeks, there's going to be a model that's better and cheaper than the one you're using today. You should not tie yourself to any of these things. And that is why I love DSPy. DSPy decouples your task from the LLM. So it lets you define your task programmatically. And this, I think, is like the great irony of these things. If you read system prompts and prompts used in pipelines, you start reading them and you start wireframing them down. I don't know, if you're like me, I start thinking about how I would program them. We're moving from prompting to programming when we start to look at the pipelines and applications we design. So why just, we can skip all the prompting and just write the programming. It's much easier. So we write tasks, we don't write prompts. We can use DSPy to optimize our function against our eval data to make sure that our prompt is accountable and performing. And we can embrace model portability. When a new model gets released, we switch over, we run our optimization against our eval, and we're off to the races. That's it, super simple. So let's go back to our OpenAI SWE bench example. We're going to use this like our table of contents. So imagine we want these different components in our prompt for our conflation challenge, right? So let's start with, how do we perform the task and the kind of prompting instructions using DSPy? Well, DSPy makes prompts from structures. We can quickly spec out what we need and then manage our prompts. We need two things. We need a signature. Signature is just a fancy word for this is what I want, the inputs and outputs. And then a module. A module is basically, all right, what prompting strategy do I want to use to execute this input-output? Now, signatures can just be strings. So I could write input-output. I could write baseball player, and I want to get out. Are they a pitcher? I could write, restaurant, and then the question could be, is fast food? And then I could type it with a Boolean. It can just be a simple prompt. It could be anything. And we can also define this as a class with multiple inputs and outputs, and it gets really cool. I'll show you that in a second. Now, signatures tell you what you want. Modules are basically how you're going to get it. So they're strategies. Think of them as prompting strategies. So the base one is predict, which is just, hey, turn this into that. But you could do multiple different ones, like chain of thought, which is, hey, I want you to think step by step to get this answer. React allows you to use tools. The module can retain trainable parameters. And you can start stacking these modules together. So you might have a multi-stage pipeline where you want to do several different things to the LLM, and we can build that all as a single module. And I'll show you, that's beyond the scope of this talk, but it can be done. So here's how you get up and started. Roughly 12 lines, including new lines, print codes. We're not doing code golf here quite yet. But we just connect our LLM. Behind the scenes, DSPy uses Light LLM. So you can use OpenAI, you can use Anthropic, you can use VLLM, you can use SGGraph. I use Olama when I'm just doing crazy stuff at home. I then define my signature in that predict call. So that predict, see where it says on line 8? That's the module. Predict is the module, and it's taking my signature, which is I'm going to give it a question, and I want an answer. Once I have that little combined model, I can run that QA and feed it a question, and I get my response. up and running really quick. Now, oh, I forgot I had highlighting. Sorry, you guys. So what is it doing behind the scenes? There's no prompts here. You don't have any multi-line prompts. So what is it doing behind the scenes? Well, when you give it a signature question answer, and you put that in a module predict, it basically turns it into a system prompt. And this is what it says. Gives you all these things, tells you how it wants formatted. You never have to worry about this. You don't have to see it. You don't have to touch it. You can see it if you want, but you don't have to worry about it. And then when I call this, what's the capital of France, it gives it in the user prompt with that system prompt, and I just get it back. Now, the cool thing about this is that it's modular. Why is it called module? Because it's modular. I can switch out predict. Let's go to chain of thought, changing a few characters. And all of a sudden, this is my system prompt. Notice it has reasoning in there. And now I get reasoning as a separate field. I didn't have to do anything. I just changed, or I changed one line. So I did have to do something. I had to hit a few keys. And there's lots of modules. There's multi-chain comparison. There's majority voting. There's react, refine. Again, there will be a better prompting strategy tomorrow. Don't bother with trying to program this into your prompt. Just program into it in the program. So now let's define a signature class. So this is my beginning of my conflation pipeline, or my LLM call. Now there's one typo in here, I'll show you, but I basically am just using some pydantic or typed fields. I first define my place. It's got an address, which is a string, and a name, which is a string. And then I have my signature, my place matcher class. Now there's a couple things I want to call your attention to. First off, this is hopefully my only typo in this deck. But this is the doc string at the top. It shouldn't say verify the text is based on the provided context. It should say review two places and determine if they're the same place in the real world. This will actually be used in your prompt. So if you want to sloppily add something into your prompt and make sure it gets added in there, some business logic that it's not going to know off the bat, and you don't have any eval data that's going to teach it, just put it in the doc string. It's a cheap but dirty trick. Then what I have is I can add descriptors to my field. So I have my two input fields, place one, place two, self-explanatory. I don't need to say anything else. Then I've got my match, which I've typed as Boolean, and I give it a description. Do the two places refer to the same place? And that will, again, get carried forward into my prompt. And I've also asked it to give me a match confidence, low, medium, and high. Off the bat, that's not going to deliver a lot of value. But because I have eval data, that I know what low, high, and medium confidences are because I've had human labelers, it's going to get valuable as I start to train my model. And that's it. That's literally the entire thing. That's my entire class, and everything's there. Now, this is how it works. I can take two places, which I can kind of hot define in the call to the matcher. And this is what I get back. A prediction object, which has a Boolean match, and a high confidence match confidence. Now, you know what's cool about this? I didn't have to parse any JSON. I didn't have to yell at the LLM to format it properly. It just worked. It just came out. I didn't have to interpret any strings. I didn't have to use any regex. Again, I don't want two problems. And so right there, I've taken care of the task, the chain of thought instructions, and all the formatting with like basically 12 lines of code. And that's heavily typed. You could do that in like 1.5. Now, a cool thing about this, just because I want to check the box because it's on our table of contents, you can add tools. If you start to use the React module, this is defined on the DSPy website. I just ripped it off here. So we have two functions, evaluate math expressions in Python, and then search Wikipedia. We can provide those as tools, and it just works. Again, lets me check off I don't need any tools in this conflation demo, but I'm still going to check off my table of contents. Now what's left is all that detailed context instructions. These are the things that get you the results that you want. This is where you put your hotfixes. This is where you put like all your conditional statements. So how do we get that in DSPy? It all comes from your eval data. It all comes from being able to optimize our prompt. So to optimize a prompt in DSPy, you really only need, I would say, you need two things if you don't have any training data. The first is our validation function, our reward function, our metric. And this metric is really simple. I'm basically just taking the prediction with the example, which I have had humans label, and just seeing if they match. That's it. This could be very complex. In other pipelines, I've broken apart the address. I've given points for getting close. I've attempted to put some metrics behind high, medium, and low. You can even do cool things where you take a giant model and use it as an LLM judge within this metric, which again is a great way to have some transfer learnings here. And then what I do is I set up what's called MePro v2. I'll explain this in a second, but that's our optimization function. Now, this is what we do. We then optimize our matcher, and then we save our optimized prompt. Before I get into all of the details here, I want to call out a few things. First off, I already did that. I've now created a new LM. Now, why did I create a new LM? Because I'm actually using a really small model here. I think I'm using Qwen 0.6 billion parameters. And I'm going to use a larger model here because in MePro, and we're going to get into this in a second, we use the large language model to try writing better prompts. And so I'm going to use a large language model, GPT-4.1, to be my prompt writer, which is great because I'm not going to run it against my entire pipeline. I'm just using it to try to improve my prompt I give Qwen 0.6. And we'll talk about that in a sec. And then finally, I can save it after it's all done. This, again, is great because it just saves as a JSON file. I can load it in. I can version it. How many people version their prompts without an external tool? It's like embarrassing to me how many prompts I just see slugged into some Python and it's just managed through Git. So let's talk about MePro real quick. So this is the optimizer we're using. And this, I think, is one of the magic tricks of DSPy. And it's just an optimization function. So MePro is an optimization technique that generates examples from your pipeline. It runs conflation on a bunch of my training data that I've given it, runs it through the LLM, and then looks at the pipelines. It then provides those examples, those traces, and a description of my task and the function to, in this case, GPT-4.1, and says, hey, this is what the model's doing. This is what it's trying to do. Here's some examples of what it does. Can you write me a better prompt for this? And it will even give you some prompting techniques, like, all the silly things we used to do back in the day. Threaten the model's mother, or offer to pay it $100 million if it gets it right, or give it an occupation, a fancy occupation sounding thing. And so it generates all these instructions. You don't have to write this, and you can specify how many it writes. So you could have it write 8 candidates, you could have it write 5 candidates, you could have it write 30 candidates. And then it's going to do basically a Bayesian test of comparing all of those different prompts it wrote against the eval data to see which ones perform the best. And then it's going to find the best parts of those prompts, merge them together, test it against the full run, and come back with an optimized prompt. It's also going to figure out, hey, should we put some examples in here? How many examples do we need? Should they be synthetic examples, or should they be actual examples? And you hit run, and it runs for a while. And then behind the scenes, you see your score go up. But this is what it does. This is hard to read, so I'll turn it. This is the original kind of prompt. There was some framework around everything. But it started with determine if 2 points of interest refer to the same place. I ran this model on my eval data with Qwen 0.8, I think it is, with 4.1. And at the end of a optimization cycle, this is the prompt I got back. Given 2 records representing places or business, each with at least a name and address, analyze the information and determine if they refer to the same real-world entity. Consider minor differences such as case, diacritics, transliteration, abbreviations, or formatting as potential matches if both the name and address are strongly similar. Only output true if both fields have a close match, blah, 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 blah. This is a great prompt, and I didn't write it. And not only that, I know how well it performs. I went from 60% correct against my eval to 82% correct against my eval without writing a single prompt. Those 14 lines of code, which is everything I have over here, managed to produce an excellent 700 token prompt. The code is easily readable. The prompt can be versioned, tracked, and loaded. I've got a team of 35 plus companies who are all touching this, who can look at this and know exactly what it does immediately without having to read pages of prompts. And now, if this wasn't cool enough, so at Overture, we strive to be cloud agnostic. So it's a little awkward. Overture is one of my favorite projects because it's a great public-private partnership, and you've got the biggest companies in the world. Like, we've got, what, 2 cloud platforms as members, Microsoft and Amazon. We've got, I think, 3 different model builders between Microsoft, Amazon, and Llama. And so there's a lot of weird, like, well, do you want to run this on AWS hardware? Do you want to run it on Azure? Do you want to run it on what have you? Well, the cool thing about this is, again, change one line in my code, run the optimization, and I can change the model. So with my original pipeline, I went from 60% to 82%. And Qwen was great because it's 0.6. It's very small. It's lightweight. It runs really well. But if Meta comes in and says, no, you got to use Llama because we want to get a Llama when we want to get a case study out there, well, it's great. We can run the optimization. It goes from 84 to 91. Microsoft says, actually, we want to try the reasoning, soft reasoning of 5.4. Let's do that. 86 to 95. There's always a better model tomorrow, and each of these prompts were different. That's the big takeaway. That's kind of crazy. Do not build a prompt and invest countless hours for something that is going to get thrown away when a new model comes out. So where could you go from here? If you wanted to take this pipeline further, you could try new optimizers. So I know the DSPy team is going to be talking about some of their new optimizers that have been in beta. They're going to be releasing DSPy 3.0 later this week. Simba is the new Me Pro. It's very cool. They've even got some RL options in there. You could utilize fine-tuning. DSPy lets you do fine-tuning with SGGraph and other things. So we at Overture have fine-tuned our models because, again, it makes sense. We want a tiny model. We want it to go lightning speed, and we want to be able to run it across, petabytes of data. You could build multi-stage models. I have had success in conflation where I have another model that just breaks apart the address into components. So given an address string, give me the street number, give me the street name, give me the what have you. Addresses, I could spend 2 hours talking about how bad addresses are. And that might be part one. If I then build a little DSPy module with my address breaker downer and then my conflator, I can optimize those at once, not separately. It's incredible. And then you can start to incorporate tools. We didn't even touch these, but this is a really cool thing. So remember, DSPy decouples your task from the LLM. Write tasks, not prompts. Optimize your functions using DSPy. Again, better optimizers are going to come by. It lets you focus on 2 things, the task you want to do and your eval data. Everyone here has eval data, right? It's the most valuable thing we can have. Prompts are worthless. Eval data is gold. Model's kind of worthless. It's all about your eval data. And then you can embrace model portability. You can test all the models. You can test everything incredibly well. So you should try DSPy today. I'm going to give you 2 bits of homework. The first homework is you should get started with DSPy today. It's incredibly easy to get started with. It lets you go fast. Get up and running with DSPy. Define your task. Don't worry about exhaustive prompts. Don't worry about formatting. I first got into DSPy because I just was tired of formatting, extracting structured data from LLM output. And DSPy took care of that for me. Great. The second thing is you can grow with DSPy. As you make more mature pipelines, you can involve multiple people, and they can read your code better. You don't have to have these magical incantations. Get good with DSPy by bringing your eval data and doing the optimization. Again, 60 to 82% gain with that cost like $1 of credits. And then stay good with DSPy. Run that eval, build your eval data set constantly, always check out the new models. Now your second bit of homework today is write a signature in DSPy. Go write a signature. Just try it. It's incredibly easy, incredibly cool. The second thing is, I want you to check out Overture data. If you use geospatial data at all in your stacks, or even just want to query like where addresses are, or where neighborhoods are, or where cities are, roads, whatever, this is the best data set to get started. It's in the Databricks marketplace, maintained by a company called Cardo. It's also, you can go to overturemaps.org. Check it out. It's amazing what an incredible resource it is. And it's all in modern cloud-native formats like Parquet. You don't have to download the entire OpenStreetMap planet and then do an extract and figure everything out. You can query it with DuckDB and get everything you need. And then check out my writing. I like to try to explain technology in a way that everyone can understand it, so we can actually have productive conversations that are not clouded by hype or fear or anything like that. So with that, thank you very much.